Okay, this is David Spears, instructor at Texas Tech University Civil Engineering Department. We're talking about page 1 from the statics quiz number 2. This is statics CE 2301. Page 1 was involving the moments of forces about points on a rigid body. There were two forces given, and the dimensions of the rigid body, this L-shaped thing. And the first question was, what's the moment of force F1 about point B? Well, the first thing I did was draw on my diagram the components of those two forces. F1 is a 3-4-5 angle. F1 is 750 pounds, so its vertical component, J component, is 600 pounds. Its I component is 450. That's just the ratio of 4/5 and then 3/5 of the 750 pounds. The F2 was given in Cartesian format, so it's just 600 negative I and 250 pounds negative J down. Its resultant is the square root of the sum of the squares, so that's 650 pounds. Okay, that's the setup. Back to the moment of F1 about point B. The 450 pound force passes through B, so its moment arm is 0, and it also creates no moment about point B. So the only part of F1 that creates any moment is this 600 pound vertical force times a 2-foot moment arm. Means 600 pounds times 2 foot is 1,200 pound-feet, and it is causing clockwise rotation around point B, so I drew a little arrow there. The second question was, what's the shortest distance from point B to the line of F1? Well, the shortest distance, D, is the moment created by that force divided by the force's resultant magnitude. So that's, I was given 750 pounds. I just computed 1,200 pound-feet for the moment. So dividing those two, I get 1.6 feet. On the quiz, we had questions 3 and 4 that were trying to find out the moment of F2 about point B, but they are similar. The only one, 250 pound force passes through, so it creates no moment. The 600 pound force creates 1,800, 600 times 3, 1,800 pound-feet of moment around B counterclockwise. I get the D distance similarly. Okay, then on the quiz it was 5 and 6, but here it's 3 and 4. Replace the forces on this rigid body with an equivalent force couple at B. What is the resultant force, R? Well, I just divide everything into their Cartesian components and add them up algebraically. R is equal to the I components, which are the X, of plus 450 for F1 minus 600 for F2, and then add the J components, which are the Y, the vertical components, which are 600 positive for F1, negative 250 for the force at C, F2. So I just add those numerically, algebraically. I get negative 150I plus 350J pounds. And last but not least, replace the forces with an equivalent force couple at B. The second part of this, what is my resultant couple moment, MR? Well, once again, this component of F1 and that component of F2 pass through point B, so the only thing that creates moment is about point B, and I just add these up algebraically too with regard to their direction of rotation. 600 pounds times a 2-foot moment arm for the force F1, that's clockwise rotation around B. It's the same answer as I had up here in 1. Minus, because it's the opposite direction of rotation, the 600-pound I component of F2 times its moment arm of 3 feet gives me, and that's rotation counterclockwise, so I've drawn little arrows up here to designate that. So my resultant is 1200 in the clockwise direction minus 1800 in the counterclockwise direction gives me negative 600 in regard to the clockwise rotation of the first factor. So that means it's the direction of the second factor. So it's 600 pound-feet counterclockwise.